So let me quickly introduce myself. Several of you know me already. My name is Radhika Krishnan. I run product marketing and alliances for the company, technologist at heart, and which is why I'm super excited about everything that we're going to go through today. Let me just quickly walk you through what we have in store for you from an agenda standpoint. So we're going to kick it off, because some of you may be new to Nimble. We're going to spend some time talking about Nimble and our adaptive flash platform, which is the core technology under the hood. And then we're going to have a bunch of data scientists led by Rod Bagg come up and walk you through some new features that we have in our cloud-based management product. We refer to it as InfoSight. And then subsequent to that, we actually just made a new announcement this week around our storage on demand. And I'll get into a little bit of detail on what that is in a moment, but that would be the third portion of the discussion today. So in terms of, oftentimes young companies tend to make claims about, their technology and where they're at. We believe the proof is in the pudding. Customers vote with their wallets. And so what this is showing you is the growth that we've had in our customer base in less than 4 years of shipping. So as of the end of our second fiscal quarter, which ended in July of 2014, we had north of 3,750 customers, paying customers. Now, the interesting thing to note is a lot of these customers have come back to purchase more Nimble gear, right? So on average, for all the footprint that we sell to a customer day one, we actually end up selling twice that footprint a year later. So that has been going really well for us in terms of customer traction. Also, the other thing I'll point out is Nimble is architected as a very broad platform. And so that's what you see reflected in the chart on the right-hand side, right? I mean, we are really optimized for a wide variety of applications and use cases. And so to that end, you'll see Nimble prolifically deployed across multiple verticals.
I don't know if you're the right person for the question, but how can you be optimized for a wide range of things?
So
it seems like an oxymoron, if that's right.
That's a great question, Nigel. So we'll actually walk through how that happens, and that is actually the underpinning of adaptive flash as well. So that's a great segue into that. So this actually kind of touches on that question as well, right? So I refer to adaptive flash. Let's spend a few minutes talking about what that really is. In order to understand it, let's talk about what is happening within the data center in terms of workloads. Now, workloads have varying characteristics and varying demands around performance and capacity, right? And for purposes of today's discussion, we're actually going to ignore the topmost chunk of the pyramid. Those are the applications, the real-time analytic applications that may require millions of IOPS and sub-microsecond latency. So we're going to ignore that. We're also going to ignore the bottommost portion of the pyramid, which is, all the archival workloads, which tend to be very capacity-centric. So much of the focus or much of what is happening in the data center, about 80% of the workloads are what fall into those two middle chunks, right? And the way that the industry is viewing these today is, you have mainstream applications. If they have some amount of performance sensitivity, the natural way, the inclination is to go either with a monolithic system like a VMAX or to go with an all-flash system. On the other hand, if you have something that is a little bit more capacity-centric and is not quite as performance-sensitive, you essentially purchase a disk-based array or a hybrid array in more recent times. So the problem with this approach is, you now end up with silos, right? And silos lead to complexity, as we all know. So you need to have two different types of architectural models in your environment, which means there is accompanying, licensing challenges and backup complexity and power and cooling and IT staff training and so on and so forth. And so the adaptive flash value proposition really is that, we can bridge those two, right? So what we're saying is we can provide you with a single architecture that can deliver on both your performance and capacity demands. And how do we do that? So then the obvious question that comes to mind is, how can you make a claim that you can deliver with a disk flash combination the same amount of performance as an all-flash array? And so I want to get a little bit under the hood and talk to how we do that. So there are a variety of things that come together to deliver on the adaptive flash platform, right? So the first thing is I want to point out is Nimble has a very differentiated approach in terms of how we deliver IOPS. Most flash architectures, as a matter of fact, almost all flash architectures leverage SSDs to deliver IOPS. What Nimble does is to leverage Moore's law, so we actually leverage compute in order to deliver on IOPS. And so what this allows us to do is actually extract way more performance out of a single high density disk drive, a 7.2K RPM drive, which is what is in our systems, as compared to a MLC SSD, that can only get you about 5,000 IOPS. We're able to squeeze out a lot more write IOPS out of a 7.2K RPM drive, leveraging the power of compute on the controller. So that is one key element of adaptive flash. The second key element is around the fact that we actually allow customers to vary the amount of flash in a fairly dynamic fashion. So again, oftentimes the tendency to gravitate towards flash-only environments is because you don't know how much flash you need for your workload. And we have a powerful tool in our arsenal, which we refer to as InfoSight. And what that allows us to do is to gain very clear visibility into how much flash is required in order to gain the level of performance that you're looking for. So if you have a certain latency threshold, we have the ability to tell customers how much flash they need to stay within that envelope. And so that's the second element. I'll also point out that today, customers can get up to 16 terabytes of flash in a single node, and that actually goes up. So as higher density SSDs come out, we give customers the ability to swap those out for higher density SSDs. So that amount, that flash volume technically can go up to much higher amounts and will as part of our roadmap. The third thing that contributes to adaptive flash is our ability to cluster or scale out, if you will. And this is clustering in the true sense. In other words, we actually stripe our data across multiple physical nodes. And what that allows us to do is you can actually take a single volume and you can straddle it across 4 physical nodes, thereby leveraging the flash and the compute capacity of each of those physical nodes, right? And so when you put all this together, what you can deliver, sure.
Is 4 nodes the maximum that you can scale out to?
So 4 nodes is what we have QA'd today. Technically, you can go up to much higher numbers, but it's purely a QA limitation.
Okay.
So 4 nodes is what we've qualified.
Right. Is it a shared nothing backend, or do the 4 nodes share a storage pool on the back end?
So the way we do this is we actually route it. I mean, it's a host-based mechanism. We have a very, very small bin map that sits on the host that basically decides how to route the packets.
Okay.
So the data is only located in one location.
What?
The data is only in one of the nodes, and it's routed to the proper node that way. Is that how it works, Radhika? I mean, the data is only really in it's striped across all the nodes. So, but the data might be only in one node for this instance, and you would route the request to that node.
That's correct.
It's not actually. I guess it. Well.
You might want to explain the notion of storage pools and that arrays can be in that.
Yeah, it's just I'm looking at the diagram there, and it looks like you've got 4 nodes, and I can't see. I appreciate we're having some technical difficulties, but it looks like it's got the compute and the storage in each node.
No, so well, let me back up and explain. So those are 4 storage nodes.
Yeah.
What you see underneath here, called out as AFS, is actually an all-flash shelf. So you can connect up a shelf that can be populated only with SSDs to each of the individual nodes. So that's what we're showing here. So essentially what is being clustered is only the storage arrays. So it's not the compute, right? What we're saying is, so there's 2 reasons customers typically want to cluster, right? So one is, they want to do it for manageability purposes, in which case, we refer to it as a storage group. You can put multiple nodes within a single storage group, and that gives you the ability to manage all those entities with a single UI, right? So that's one element. The other way you can do this is what we refer to as storage pools, where you can actually take the data and you can physically stripe it across multiple nodes. And so the point that
the data is protected through RAID or replication, or?
So data in general is protected through RAID on each of the physical nodes. Yes.
Okay.
Yeah.
So I could have a file or a range of blocks, that are striped across the storage of all 4 nodes.
That's right.
Right, so that would, to me, that would be a shared backend then. Not a problem. I'm just trying to understand.
Okay. Yeah. No. Sure. That's right.
Just a point of clarification.
Separate.
The data is typically sent directly from the host to the destination node. So using the host agent, as Radhika was saying, there's a block map on the host that knows where each block, which node each block is located on. And so it gets sent directly from a host to a destination without going through a shared
but
backend.
each node cannot access all the storage behind all 4 nodes.
It
can.
can.
But only through by
No,
hopping.
directly. So what happens is, network-wise, each host has connectivity to every node.
I understand.
And then each host knows where each block is located.
Yes, I
so it goes
understand.
straight to the destination node to either write or read the
Right.
block.
Okay. So the node at the bottom left there can't directly access the storage at the node on the top right.
The nodes can
nodes
access.
can't.
They can across the same network.
All right.
And that's for purposes of if we want to migrate a volume
But it's like
out
hopping.
of the shared
Okay.
set of nodes, we can move them across that network.
But a normal read request
Goes straight to
goes
the
straight
host.
to that.
Directly.
Right.
Yes.
Okay.
That makes sense?
And we actually leverage very basic technologies to do this. So, on the Windows side, we use what is referred to as DSM, and on VMware environments, we use the PSP module, the multipathing module. So that's the clustering scale-out functionality. And so when you put all this together, our systems are able to scale up to 500,000 IOPS and petabytes of capacity, right? So, and this is where, we're able to truly deliver on both performance as well as capacity that large-scale data centers might require. So, oftentimes there is a lot of debate around scale up or scale out. And what we believe in is not customers having to make a compromise or a choice between the two. And so we allow them to both scale up as well as scale out. I mean, we just talked about the scale out aspect. We also allow customers to upgrade their controller as well as grow the amount of flash within a system. And so technically you can start with a very, very small Lego block and you can grow it as your environments scale, right? In addition, of course, as most storage vendors do, we also offer the ability to grow the capacity as well. So you can add expansion shelves for disk capacity. And as I mentioned earlier, we also have the notion of an all-flash shelf that you can add to the system, which can be populated entirely with SSDs. So that's on the performance, capacity, and scaling dimensions. I referred to Nimble being a broad platform earlier, and so we also do believe that customers encounter significant pain points when it comes to protecting data. This is something that has been architected into the system from the get-go. And so by the way, our founders came from data domain, so they're very familiar with the innovations that have happened in the backup space around deduplication and appliances and so on. The problem with all those approaches still tends to be the fact that there is data movement involved, right? And anytime there is data movement involved, there is overhead associated with it. And so what Nimble allows customers to do is to basically snapshot the data. So you pretty much have instantaneous backups and instantaneous recoveries. We also, several of our customers keep their data around or their snapshots around for 3-4 months. And so there's a statistic that says most recoveries happen within 90 days of backing up. And so you can now instantaneously recover from that snapshot versus having to go to a secondary location and looking it up on a catalog or, God forbid, on a tape device or something like that. We also give customers the ability to replicate in a WAN-optimized fashion from another site. So, for disaster recovery protection or for backup purposes, you're able to do that. Nimble has also worked with backup partners to integrate snapshots. So, particularly Commvault, Simpana has the ability to manage Nimble snapshots as backups.
So you said that you do some sort of WAN optimization for replication across the WAN. Is that, I know you do inline compression. Is that compression what you're talking about for the WAN replication, or is there additional WAN optimization done for replication?
So this is really to minimize the chatter on the wire. So that's what I mean by WAN optimized. Of course, all data that goes across the wire is compressed. And it's also incremental blocks only, right? Only change blocks are sent across the wire, so it is highly optimized. In addition, the protocol itself has been optimized to minimize chatter.
Yeah. Just to add to that, so if the volume snapshots are already compressed, if that's the way you've configured that volume, then the data goes just as is. We don't do any more compression, as Radhika said. And from the optimization of that protocol, really what we do, it's a streaming protocol that's really optimized for lower bandwidth, higher latency, lossy networks. So we can dynamically change TCP window sizes and that sort to accommodate those networks to get the maximum throughput we can on the wire.
And its replication is synchronous or asynchronous, or?
So it is asynchronous today.
And based on snapshots, or?
They're all snapshot based.
So
that's right.
Okay.
All right, so moving along. So this is the cloud-based management offering that I was talking about earlier. Essentially, the way it works is we collect extensive telemetry data from our customer systems. So just to give you a feel, it's about 30 million sensor values per hour that are streaming into our headquarters here.
So Radhika, Howard asks if Nimble Storage is doing scale out with via host block redirection kind of thing, how does scale out work for hosts where there's runs an OS without the driver? So if you don't have a driver for a host, can you still support the multi-node configuration?
Yeah, we still can. It just won't be optimized. So this is essentially to optimize the hops, the number of hops.
It redirects when it gets to wherever it gets. Yeah.
Right.
Yeah.
Is that the same thing that happens on a write? Does it know where, if you're striping across all of the nodes, how does the host know where to write the data to? Does it write sections on each one, or does it send it to one node and then that node takes care of striping across the rest?
Yes.
So it's a coarse bitmap on the host that knows which pieces of each line is on which array, and that's used for reading and writing.
Okay.
And that's, as Radhika said, it's done through either standard Windows MPIO agents, or in the case of VMware, it's a PSP, a part selection plugin.
Okay.
So back on InfoSight, as I was mentioning earlier, we collect a very vast, rich volume of data from all of our customer systems. So it is streaming in. I mean, this is nothing like auto support, just to put things in perspective. This is not like a phone home capability where, you can maybe get some notification around a disk failure or a fan failure. This is much more extensive data that is being streamed back, and it is all being analyzed in real time. So there are some very sophisticated data modeling engines that are built in that are looking for patterns and so forth. And so what that means is, there are three distinct sets of customer benefits we're able to deliver. One is what we refer to as proactive wellness. So this is the notion of where, even as we're looking at data patterns, we're able to discern whether there is something suboptimal going on in the customer environment, and we're able to flag it well before that suboptimal condition turns into something like a failure. And what that allows us to do is to just to provide share some statistics to kind of frame that up. 80% of our support cases are automatically detected using this feature. So there's only 20% of the instances you have a customer picking up the phone, calling us, the traditional way. In 80% of the instances, or actually more than that, 90% of the instances, we have we're able to detect all these support cases proactively and notify the customer. And of those, 80% of the time, we're actually able to automatically resolve those as well. So we know how to remedy the situation, and we have a VPN connection into the customer environment, and so we're able to proactively fix it. So that is what we refer to as the notion of proactive wellness. We also offer customers the access to all this rich data and this analysis that's happening in the back end, and that is what we're going to walk you through later today. We refer to it as the InfoSight portal. Every customer that purchases a Nimble system has access to this portal, and they're able to manage, gain visibility into a variety of dimensions, capacity and performance and so on. And as Rod and his team will walk you through today, it actually gets into very granular visibility into what is going on with our flash and caching and our the compute in our controller and so on. It enables customers to also do proactive planning looking forward. And then the third...
Partners have the same visibility into the customer systems as the customers do from the portal.
I'm sorry, could you repeat that question again?
The partners who actually sell this into the customer account, do they have visibility into their customers?
That is a great question. Actually, they do. And so as long as the customer gives the partner permission to view the data, they can actually view what is going on within the customer environment and provide proactive services based on that. The third aspect I want to point out is, we also have a community built out based on this rich set of data. So we actually can glean best practices. So for instance, we can figure out educational institutions, when they deploy VDI, which they tend to do quite a bit, what is the average desktop size, right? So questions like that most customers might have, we're able to glean that by virtue of this rich collection of data that we have. So we typically anonymize that data and share it with the community at large. So that's in a nutshell InfoSight. And again, you're going to get a much more detailed walkthrough from Rod and the team here. So, just to kind of summarize it, I think we walked through every single bucket. The two core foundational products that make up Adaptive Flash or our file system, which we just talked about earlier, that's what enables us to deliver on the performance and capacity and scaling. And then InfoSight is the management tool that enables all of this to be done in a very intelligent fashion. And then we talked about the core underlying value propositions we deliver as well. So the one more area that I wanted to point out before I hand this off to Rod is what we've done with regards to optimizing applications and workloads. So Nigel, going back to your earlier question about what have we done and why is this a broad platform, how is it optimized, the way, we completely recognize that storage doesn't get consumed, in isolation, and it's always in the context of some kind of application or workload on top. And so to that end, we've partnered with a wide variety of ISVs and IHVs to construct solutions that make it a lot easier for customers to consume storage in those environments. And so our core offering in this area is called Smart Stack. We partnered with Cisco. And it's basically a combination of Cisco compute and networking along with Nimble storage. And you can layer on various workloads. So we've partnered with VMware around their VDI offering, with Citrix, with Oracle around databases and applications. And we work with Microsoft as well around their private cloud, Hyper-V, as well as the application sitting on top. And so this gives customers a readily accessible blueprint that they can leverage to go deploy these.
So it's via reference architectures then that you optimized for a wide range?
So two things to point out there, right? So one is the platform itself is very broad. So again, going back to the pyramid that we looked at, most architectures tend to be optimized around a niche. Either they're for the very high, the performance intensive segment, or they are targeted at virtualized applications only. What we're saying is, our platform itself is capable of taking on a very, very broad set of workloads. Mm-hmm. And then on top of it, we've also invested in making sure that there are optimizations at a vertical stack level by partnering with the individual ISVs.
Okay, so is there anything that you could particularly call out between a stack that you've got that's optimized for Oracle versus a stack you've got that's optimized for Splunk?
So there are some, just in terms of storage, are you talking about, there are two ways you can, two parts to the answer, right? So one is at the storage array level itself, there are parameters that you can tune with regards to, how to cache and how to protect data.
As a customer? So these are parameters that we would tune as a customer, yeah?
So there are, so it's yes and no. So we have what is referred to as application profiles.
Yeah.
And so, when you deploy VDI over Nimble, the VDI application profile gets turned on.
Oh, okay.
And so there are accompanying, performance policies and data protection policies tied to that. In addition to that, when you deploy VDI, our tech marketing team has actually constructed an entire reference architecture which says, here is how you configure the array, here is how you configure the compute portion of it, and so on. So you have a clear set of steps in deploying that VDI environment.
So do those profiles get as granular then as saying, right, I've got Oracle, and this volume is going to be a redo log, and this volume is going to be, and then does it tune things at that? Does it get that granular?
That it definitely does. Yes. All right.
Another question then. So in this stack, you call out specifically Cisco, UCS Manager, Cisco switches. So does the Nimble storage appear in the Cisco UCS Manager software in any kind of special way? How tight is that integration? And that leads to my other question, which would be, are you able to do this with other server vendors or other networking vendors and so on?
Yeah, so let me answer the first question first. So our orchestration happens, actually you'll get to see a preview of this. It's what Cisco used to refer to, they acquired a company called Cloupia, and now it's referred to as UCS Director. So that is the primary way that we orchestrate across the stack, across compute and storage. And the second part of your question, can we do this with other server vendors? Technically, yes. Today, we've done this with Cisco.
Okay. And then what would be the preferred model for a customer using this? Would they go through the Cisco UCS Manager as an example, or would they, if they're doing VMware, would they do everything in vCenter?
So that comes down to customer choice. So, day-to-day management typically tends to, vCenter tends to be the preferred plugin. If you're doing orchestration, if you're doing provisioning for the first time, something like orchestration, UCS Director might be more amenable for that.
Okay, and so then does the Nimble storage sort of fit into the Cisco UCS Manager's sort of concept of profiles like it does with servers?
So we're not integrated into UCS Manager. Actually, I don't think any storage vendor is integrated into UCS Manager. It's a very Cisco proprietary framework. What we have integrated into, and you'll see a demo of it today, is UCS Director, which does the orchestration.
Just building on what he said, are you going to expose any APIs for, say, OpenView, OneView, and say for them to be able to manage firstly, or what's it called, orchestration with HP servers?
OpenView?
Yeah.
That's a great question. Actually, we have the product manager for our API framework right here in the room with us. When did you want to answer that?
So we do have plans for a REST-based API that will introduce the capability for other vendors to consume our API at the platform layer, so they could do the orchestration at their end. So hopefully that answers your question.
Thank you. For now.
And so just another sort of on the same topic. So we've already talked about vCenter. Do you plug into SCVMM or any of these other?
Actually, we do. Yes, we do have a System Center Virtual Machine Manager framework as well.